Today, our lesson is on systems of equations. If you haven't already printed the video guide, go ahead and pause the video, come back, and do the problems with me. So we're talking about systems of equations. Before we actually graph a system of equations, we need to talk about what a system of equations is. So the definition for a system is just two or more equations that are solved at the same time. So we've been talking about linear equations the previous few lessons, and we've been graphing linear equations on a graph, finding the slope using the y-intercept. We're still going to use that information today with systems of equations, but we're actually going to be graphing two equations at the same time. We're just going to be dealing with two. A system could be more than that. It could be 3, it could be 4, 5, so forth. But we're only going to be dealing with two equations. So, our first problem, number 1, we have y equals 1/2 x plus 4. And then our second equation is y equals negative x plus 1. Now I'm going to be doing these in two different colors so it's easy for you to see which equation I'm graphing. So for the first one, y equals 1/2 x plus 4. We first need to know the slope and the y-intercept. Remember, the slope is always in front of x as long as our equation is in slope-intercept form, which it is. So my slope is going to be positive 1/2. My y-intercept is always that last number, okay, which is positive 4. So 4 is my y-intercept. And I'm going to go ahead and graph this. To graph, I start with the y-intercept. I go to positive 4 on the y-axis, 3, 4. So I go up 4 and put a point. For my slope, I have 1/2. So to graph a slope of positive 1/2, I'm going to go up 1 to the right 2. Okay. After that, we can also do the opposite. Instead of positive 1/2, I can do negative 1 over negative 2. So I can go down 1 to the left 2. Down 1 to the left 2. Just so I have a few points on the graph. And then we'll go ahead and connect them with a line. So that's graph number 1. Our second equation, we need a slope and a y-intercept for this one as well. Remember, if we just have x, there is a 1 in front. It's just not written. So my slope is negative 1, and to make it a fraction, we give it a denominator of positive 1. We do that for every whole number. For my y-intercept, I have positive 1. So to graph this, start with the y-intercept, go up to positive 1, put a point. From there, I use my slope, negative 1, positive 1, so that means go down 1 to the right 1, put a point, down 1, right 1, down 1, right 1, and so forth through the graph. Okay. We can also do the opposite here. So remember, change both signs. Just like I did here, positive became negative, positive became negative. If I have a negative 1, I need to make it positive 1. If I have a positive 1, I must make it negative 1. So to graph this, positive 1 means go up 1, negative 1 is to the left 1, and then I can keep going up 1, left 1, up 1, left 1, and then I draw my line. Connect all those points. So you will notice there is one place that they have in common, okay? Now, because we are solving two equations at the same time, we are looking for the point where the two equations are the same, okay? The point that they share in common. And in this case, it's where they intersect, right here. There is one place on this graph that is an answer for both equations, okay? All these other points, these ones right here, are answers for the first equations, these blue ones here, are all answers for the second equation. But the one here that's blue and black, it's for both equations. So that's our one answer. So our one answer is the one we actually want to write the coordinates for. So remember, a few lessons ago, we talked about plotting points and actually talking about the coordinates. You always start at the origin. Your x coordinate comes first, and then your y. Always, it's alphabetical. X and then y. So the x, you start at the center. You would have to go left 1, 2 places. Left is negative, so this would be a -2. And then the y, you would have to count up 1, 2, 3 places. So it would be +3 because up is the positive direction. So we have -2, +3. This is the answer. The graph is not the solution this time, okay? That's not actually our answer. We're using the graph to find the answer. The actual answer is -2, 3. The graph is just a way of getting to that answer. For problem number 2, we have two equations. First one, y equals 7/3 x plus 4. Our second is y equals -1/3 x minus 4. So remember, graph them separately and then we find where they intersect. So go with the first one. Our slope is 7/3 and the y-intercept is +4. Graph your y-intercept first. So we go to the origin, we're going to +4, so I count up 4 places, put my first point. Now, my slope is +7 over +3, so I'm supposed to go up 7, but I don't have enough room. So what we need to do is just immediately change this to the opposite. Instead of +7, make it -7. Instead of +3, make it -3. Remember, negative over a negative is still a positive slope. So this means I go down 7, and then I go to the left 3, 2, 3, put a point. And I can't go down 7, I don't have enough room, so those are the only 2 points I can graph. So I go ahead and connect these with a line, and that's our first graph. For the second equation, our slope is going to be -1 over 3, -1/3. Our y-intercept is -4. So I graph my y-intercept first. I go to -4, which means I need to go down 4 on the y-axis. I put my point. Now my slope is -1 over +3. So my rise is -1, that means I go down 1. The run is +3, so I go to the right 3, I put a point. Okay? From there I can do the opposite. So instead of -1, I'll make it +1. Instead of +3, I'll make it -3. So that means I need to go up 1 to the left 3. There's my point where they intersect. So I'm going to go ahead and draw my line. And then I need to write down the coordinates for the point where they intersect. So we start at the center. Remember, always do the x coordinate first and then the y. So the x coordinate, I will go left 1, 2, 3 places. Left is negative, so it is a -3. For the y coordinate, starting here where I left off, I will go down 1, 2, 3 places. So going down is negative. So my point is -3, -3. That's our answer for number 2. Remember, the graph is the way to find the answer. The graph is not the answer. The point where they intersect is. So you have to put this point. This is your x, this is your y. For problem number 3, our first equation is y equals -1/4 x minus 4. Our second equation is y equals -1/4 x minus 1. To graph the first equation, our slope is going to be -1 over 4. Our y-intercept is -4. So first we need to graph the y-intercept. So to go to -4, we would go down 4 places, put our first point. Our slope is -1 over +4, so that means we need to go down 1 to the right 4, and then put our point. Let's also do the opposite. So instead of -1, let's make it positive. Instead of +4, we'll make it negative. So +1 means we go up 1, -4 means to the left 4, and we put our point. And then I connect them. That's our first graph. For the second graph, our slope is -1 over 4. Our y-intercept is -1. So the first thing we graph is the y-intercept at -1. So I start at the origin, I go down 1 because it's -1, and I put a point. After that, I graph my slope of -1/4, which means I go down 1 to the right 4. I can also do the opposite. So to do the opposite, remember, change both signs. Instead of -1, make it +1. Instead of +4, make it -4. So that means +1 means up 1, -4 to the left 4, put our point, and then we'll connect them. Now, you will notice that these two lines do not intersect. Mine are a little crooked, but you get the idea. These are called parallel lines. Parallel lines. They will never intersect. Okay, they're never going to cross. There is no point that they share in common. So in a case like this, when the lines are parallel, there's actually no answer to both equations. Okay, there's no place where they share a common point. So what we would write here is no solution. There is no answer. Solution is just another way of saying answer. So this one is no solution. No answer to this problem. Now, one thing I want to point out before we move on to the next problem, you'll notice that our slopes are the same. -1/4, -1/4. That's why they never intersect, because each time we go down 1 and over 4, the other line does this exact same thing. So they're never going to cross. So in this case, parallel lines, no solution. Okay, for problem number 4, our first equation is y equals 2. Our second equation is y equals -3/2 x minus 4. To graph the first equation, you will notice we are missing our x, which means the slope is not in this equation, okay? This 2 is our y-intercept. So what we're going to do is we're going to go to the y-axis because it's y equals, and we'll go to +2. So remember, y is up and down. Positive means we would go up 2 and we would put our point. Now, our slope is not written in this equation, okay? It's not 1/2 or anything like that. So we need to think about where on this graph is y2. We've gone over problems like this. Remember, anytime that you have y by itself, there is no x variable, it will always be the 0 slope. So in this case, because y is by itself, m is 0. If this had been x all by itself, remember that's the undefined slope. But if it's y, then the slope is going to be 0. Remember, a 0 slope is just going across, okay, horizontal line. So all I have to do for this first one is draw a straight horizontal line like this. That is the graph for y equals 2. All right, for our second line, this does have a slope and a y-intercept, so I can graph this just like the others. My slope is going to be -3/2. Our y-intercept is -4. So to get to -4 on the y-axis, we must go down 4 places, put our point. Okay? After that, my slope is -3/2. Well, if I try to go down 3, we run out of room. So let's do the opposite. We'll do +3 over -2. So that means up 3, 1, 2, 3, to the left 2, 1, 2. And then we can do it again. Up 3, 1, 2, 3, to the left 2, 1, 2. and this is the place where they meet. Okay, so I need to write the coordinates for that point because remember, where they intersect, that's the point that they have in common, that's our solution. So I start at the origin, always count the x amount first. So the x would be 1, 2, 3, 4 to the left. Left is negative, so it's -4. Starting where we left off, I would have to count up 1, 2 places. That would be a +2 because we're going up. So the solution for problem number 4 is -4, 2. At this point, go ahead and pause the video, try number 5 on your own, and then come back to check your answer. For problem number 5, first equation is y equals -6x plus 3. Second equation is y equals -x minus 2. For the first equation, the slope is -6 over 1 or +6 over -1. Our y-intercept is 3, so I went up 3 and then down 6 to the right 1 and put a point. That was the only one I could do because I didn't have room to do the opposite. So I just drew my line for those 2 points. My second equation, my slope is -1 over 1. Remember, if there's no number in front of x, there is a 1 there, they just didn't write it. So -1 over 1, or change it to +1 over -1. The y-intercept is -2, so I went down 2, and then I did my slope, -1 over 1. So down 1 to the right 1. I also went up 1 to the left 1. But where they intersect is right here. So this point is our solution. Remember, you have to actually write the solution. Our solution here, you would go right 1, so that's where I got the +1, and then I counted down 3, and that's how I got -3. And that's the end of our lesson on graphing systems of equations.